Hello and welcome to this video on RKE Rancher, building a Kubernetes cluster the easy way, with myself, Steve Schilling. In this video we'll just discuss very quickly what RKE Rancher is and what it can do for you, how I will build my cluster using RKE Rancher and what the cluster will look like, some initial requirements that you'll need to get your cluster up and running before we can actually start installing with RKE. And then we'll take a quick look at some ideas and best practices, just in case you're still deciding how to build your clusters and how to work them. We'll then take you through the one file that RKE needs to build your cluster. We're going to do it in a simple form, but we'll give you some references so that you can find out where to go to town on your cluster creation. And then I'll show you how to provision using RKE, and we'll have a quick view of the code that I've got. I'll show you the Git repository I've got that builds a Vagrant stroke virtual box hybrid of a 3-node cluster, the cluster we're looking at here, and finally show you how deploying an application so that you can see it running and testing on the cluster itself. So what is RKE Rancher? Rancher is a Kubernetes engine, so RKE is Rancher Kubernetes engine. It's a CNCF, the Cloud Native Computing Foundation's certified Kubernetes distribution that is built entirely from Docker containers. There are other ones out there that do a similar sort of feature, but we picked on this one to do the job for us. So everything, all the management piece and everything else, is all done through Docker containers talking with each other. The benefits: you can install your cluster absolutely anywhere. That's bare metal, virtual machines running in your favorite virtualization environment, or even in the cloud. So if you don't want to get locked into your favorite cloud provider and you fancy changing it or getting a better deal, then RKE allows you to build on-prem clusters. Obviously you'll have to manage it, so you'll lose some of the features that you'll get when you use cloud-based ones, such as having load balancers built for you and everything else. So in this case it's operating system independent, but you do need a Linux operating system to build this and run RKE. You just need Docker installed on all the machines and some SSH keys, as we'll see later on. And if you really want to, you can go to town. There is a Docker image that gives you a web UI that you can import your clusters and then start managing your clusters through the web management interface. But if you're a true DevOps team, obviously you won't want to do that. You'll want to be able to do everything as code. So the idea of RKE is to allow you to install Kubernetes in a very simplified way and manage it in a very simplified way. That includes adding nodes, taking nodes away, and so on. And it follows the infrastructure as code format. So you can have one copy of your code, have various configuration modifications, so you can build your dev and prod and test environments. So the cluster that I'm going to build, we're going to start with a cluster here. That cluster will have just a single master or control plane, if you prefer, to start the whole system off. You could, if you wanted to, have multiple control planes so that you've got failover available, but just to make this fit and understand the example, we're going to build one master. That master will then have 2 worker nodes built into the system, and our master does have a worker feature added to it, but it doesn't have to make the cluster run. But for ease and simplicity, we've just got 3 workers, so we've got enough nodes to run it across. So our workers will basically be the servers that will be running the actual applications that you deploy to your Kubernetes cluster. We've got a private network where all of the containers will run their information across each other. So our full virtual network will run across a real physical private network inter-node. So if I've got different containers running on different workers within the same namespace, they're still able to communicate, and they'll do so across the private network. The public network, this is the one that if I'm exposing any of my applications to the outside world, within our organization, or if you prefer, out to the outside world completely, to the internet, then we've got a public network that is used for that feature. And those that are into Kubernetes will recognize the thing that will come up in a minute called Ingress. So our public network exposes our services that we want to be exposed to the outside world. We will have an HA proxy that I'm adding to this. So this will be equivalent to having your own load balancer, and that load balancer will get the single DNS name that we want all of our applications to use. I'll configure my DNS server to have a wildcard DNS, so that any application on my Kubernetes cluster can work with the namespace that I've given in DNS to my HA proxy. HA proxy will then forward that on, and my Ingress rules, where I want to use a specific domain name for my application, will pass that through to the cluster, so the Ingress can pick up the actual name and pass it on to the service. So as we mentioned, our Ingress service running across the cluster will run on port 80 by default, and if you decide to include SSL certificates and use SSL, then the Ingress default for RKE will be port 443, so the standard ports for HTTP and HTTPS. So as we said, the Ingress is where, when we start to add our applications to the system, if we want to expose our service to the outside world, we can do so through the Ingress, and that can be done using node port or using the host feature as mentioned earlier, so that we can use DNS to target our applications and services within the cluster. Host requirements. Hardware or virtual machines, whichever you prefer. These could be on-prem hardware, on-prem virtual machine environments like vSphere, or it could be in the cloud. Yeah, AWS, Azure, Google Cloud, whichever one you prefer to use. Yeah, spin up some VMs, get their IP addresses, create two network interfaces on them, have one private and one public network. Linux operating system, whichever one you like. Yeah, as long as you can install Docker on it, perfectly fine. So obviously Ubuntu, Debian, Red Hat, or Red Hat derivatives like Alma Linux and CentOS will work perfectly fine. In my environment, for the virtual environment, 2 or 4 gig, depending on which machine I'm using, but 2 gig will work for testing purposes, but 4 gig is obviously the recommended minimum for any node in a Kubernetes cluster. About 20 gig disk space, depends what you're going to be doing with it. Obviously, you know, if you're running enterprise stuff, 20 gigs not going to be big enough. Plus also you would want things like NFS and other features like that to be able to share the disks across your nodes. So that's the key element here with building a cluster. If you want to use persistent storage, you'll need sort of storage area networks or NFS, so that you can ensure that all the machines, all the nodes in your network actually see the disk. One NIC will do. I can, when we look at the configuration, I'll show you which one you can actually miss out, and the Kubernetes cluster will still work across one network interface. But as you've seen in the example that I'm working with, I want one for my nodes to communicate internally, and then all of the external traffic to run on a separate NIC. So that's why we're using 2 in the example that I'm working with. So the configuration of the operating systems. You need to distribute the SSH public keys to all of the hosts. That includes the master. The master is going to SSH to itself to be able to configure itself. And in a way, if you've ever used Ansible, it's a similar characteristic. RKE is using the push type technology, whereby I log onto the machine and it pushes out all the commands to the servers over SSH. The master must have the private key as well, though, because everything happens from the master machine. You will spin up everything you need from there. Obviously configure your DNS if it's not already. Now, obviously when you're configuring your operating systems, you've probably got something like Kickstart or Spacewalk to fire up your machines if you're doing them on-prem. If you're doing them in the cloud, you're probably using something like ARM on Azure, Azure Resource Manager, or CloudFormation on AWS. And so you might spin them up like that, or you could even use Terraform, who knows. So the idea is, yes, spin up your machines, configure them so they've got the DNS record for the load balancer, and the DNS record needs to point to the load balancer, so that load balancer forwards on all the requests to your Kubernetes cluster. All the machines need a fixed IP address. We don't want the addresses changing because that will just mess up our cluster. And disable the firewalls. Okay, RKE will deal with any firewall information that needs to be set up for the cluster itself. If you've got firewall D running on a Red Hat machine, it's just going to mess yourself up. So disable firewall D and then let the cluster deal with it. And if you're on your Ubuntu machines, the UFW should be disabled as well. Software to be installed on nodes. So every node, as we've said, needs Docker, ideally the same version, but it shouldn't matter. But Docker must be running on all the nodes that you're about to install Kubernetes cluster with. The master will have extra software, so we'll need to download and install the RKE command. Literally is just a single file in the download. So here we see an example from github.com Rancher RKE releases download version 1.2.8. If you just go to releases, it will tell you what the latest ones are. And then RKE_Linux-AMD64, so that's obviously for the Linux machines, 64-bit Linux machines, and that will get downloaded, and then you'll simply just rename it to RKE and stick it in /bin, or use a local bin depending on where you want to run the commands from. kubectl also, so once RKE and your Kubernetes cluster is up and running, you'll want to be able to control it and manage it, so kubectl will be good. And then obviously anything on top of that, like Helm, Flux, all those sort of configuration pieces that you might want to use for your Kubernetes cluster. But the idea is, yeah, kubectl minimum to download, so that you can at least interact with your clusters, apply some form of YAML for your manifest, to enter into the system and test things out and see whether the cluster is running or not. Some cluster ideas. So if you're working with Kubernetes, if you're new to it, in fact, how would we do it? RKE Rancher makes it nice and easy to spin up clusters. I don't have to think about it, and literally our configuration is bare minimum, and we get all the ingress and external features that we want to be able to do, so we can expose our services very, very easily. So if I've got the code, I can obviously have my developer code to build my developer cluster, my test code to build my test cluster, and so on and so forth. And having it as infrastructure as code literally gives us that DevOps capability. We can test it, we can fire one up on demand, go, right, I need another cluster, call it this, put it in this location, here's the machines for that. It's just a case of getting the machines up and then telling RKE to build the cluster you want it to build. So the good things about that is obviously, if I can spin up a cluster on demand that looks like my production cluster, then I can start to apply software patches and releases and see whether that breaks anything. Do I want to do the updates or not? And from there, the idea is that having separate clusters just gives me that sort of safety net, that stability that I need for my production environment to carry on running, and for me to be able to test out the under the scenes cluster changes that are going to happen. If the developers are changing their applications, their Docker containers, they're running inside the cluster. We've got features inside Kubernetes that let us deal with that, and if they screw it up, then we can tell Kubernetes not to do the release. But when you're updating clusters, you do need to guarantee that things are going to work. So how many clusters do I have? Do I have one for dev, test, and prod? Entirely up to you. The characteristic is that if you've got lots of developers and they want to keep spinning up lots of different clusters, great. But in reality, you only need one dev cluster because it should look the same as production, and the devs should be doing the stuff with their applications in there. Test, on the other hand, obviously wants to be like prod prior to somebody doing their updates, so we need to make sure that we can run all of the application manifests to ensure that the project that's about to be released in there, if it's got any relations to any other applications, that they're at the right point before the developers release theirs. So what makes you feel comfortable? There's absolutely no reason why you couldn't have just a full-on prod Kubernetes cluster, and within there you use the namespaces to separate out your dev, test, and prod. Obviously that requires a little bit more security from the Kubernetes administrators. They would have to go off and start setting up role-based access and restricting connectivity between certain namespaces. You then have to come up with a namespace feature and so on and so forth. So the idea is, pick what happens. Yes, you can do it within namespaces. If you need to then be able to update the underlying cluster because you've got patches and releases, we could do that in the backup cluster. And if that all works nicely, we fail over to the backup cluster that's now running the newest patches and security updates, and then update the previous prod. So lots of different ways of being able to do it. Budgets change, people have loads of money and they can obviously create lots of clusters and have that stability in places. Others might only be able to create a couple of clusters, or spin up a cluster on demand, go, this is what we've got at the moment, let's go off and start to sort of set the updates and see what impact that has for us. So let's take a look at what we're about to build then. This is the simplistic cluster file, so I'll show you through the slides, and then I'm going to move over to a full demonstration taking you through the code that I've written that's up in GitHub that you can run on your own machines if you've got VirtualBox and Vagrant. So it's one file that rules them all. So each cluster that you wish to create will have its own YAML file. The whole cluster configuration is done in YAML. Some examples you can get off of the web shown here. We'll put those in the notes at the bottom. And if you need to alter the configuration, if you want to go more detailed, if you don't like a particular networking layer that Kubernetes is installed and you want to change the networking layer from Calico to Flannel or something like that, then you can. If you don't want to use Nginx as your Ingress, then you can change that too. So lots of different features and things that you can set up, and it's all done through the YAML configuration. So our cluster, this is one big file. So we've broken it down into separate parts on the screen here so that you can see what's going on. So this is the master piece. And what we can see here, we've got two addresses. So as we mentioned in the diagram, I've got my internal address of 10.0.0.60. Okay, so that's the one that the internode Kubernetes communications for our Docker containers will use when they need to communicate internally. The address is the public address, and that's the one that will be used mostly by Kubernetes when people need to access it from the outside. If we don't use the internal address, if you're only using a single NIC, then you need address, and address will be used for both internal and public addressing for your Kubernetes cluster. The next part, the role, okay, that defines what it is that we want our node to actually do. Now in this case my master has control plane, etcd and worker. At most we just need control plane and etcd, we don't need the worker for this purpose, but I put it in so that I've still got 3 nodes that can run. The user, this is the user that we're going to be SSHing as. So the idea here is that RKE really wants to run as root. It's got to do a lot of stuff as root itself, or at least the user that has the Docker features and capabilities, but we need to be able to SSH on, we need to be able to run commands and do things on the machine itself. So in this case I've set up my servers so that they all allow root login, which means you need to modify your SSH daemon setting to ensure that root can log on. The Docker socket, where Docker is running, so that's the default. If it is the default, we don't technically need the Docker socket, but it's there. Where is the SSH key path that we will use, the private key to be able to access all the other nodes that we need to log in with, and the typical labels that you will see with Kubernetes. In this case, I'm just defining what each of my servers are. And you might have things based on any services that you're building within Kubernetes through RKE. You might need specific labels to be able to target them for certain attributes. Worker 1 and Worker 2 are very, very similar to each other. So here again we can see address and internal address for those. We've just got the role as worker for this. It's literally just going to run Docker containers. Same user, root to log on. Docker sockets in there again, the SSH path, and we've got some labels, and I've just added an extra label in there called LBS. Whilst I was playing around with it and finding out that if you try and use Vagrant to build your cluster, the NAT network gets in the way, and it was only targeting one of the worker nodes at the time, so I was trying to force the load balancer to just hit one specific worker node at that time. But this one's ignored now, and it's actually load balancing across all of them. Worker 2 said the same. We've thrown in the port 22, that's a default anyway, but as you saw on the other one we didn't need it, but the same features are set up there, different IP addresses for internal and external. And then the last part of the file, the services. So etcd, do I wish to take snapshots? So you can actually back up your etcd service by having a snapshot. There are extra attributes required to tell it where to store the snapshot, what to call it, and so on and so forth. The SSH key path, that's a general one. So, actually, before we get it, under services as well as etcd, you can also describe other services that you want to add to it. Take a look at the documentation for RKE, and you can see what other services you can go off and configure. There's all sorts of different ones you can set up and modify depending on what you want to do with your cluster. So I've got my key path for the whole of the service. Whether I want to use SSH agent authentication, in this case I've told it to do false, so that it uses the keys that I've specified in here, not the ones that are used by the user that's running the system. Ignore Docker versions, null. So in this case, if we set it to null, we're saying allow any Docker version, we don't care. If you need to set versions and you want to tell it to ignore or don't build on servers that have a particular version of Docker, put those versions of Docker in there as an array. Our Ingress provider, as we said, this is using Nginx as the default provider for our Ingress incoming traffic for HTTP and HTTPS from the outside world, and also for TCP if you want to use no ports. And default backend we've set as false, so you don't get a page or anything like that that comes back, so you actually have to specify your own one. So I've built one for my system that loads as a little LB status so that my HA proxy can determine which nodes are actually running and can actually be communicated with. Options, use forward headers, true. So in this case, when we receive our HTTP headers, they get forwarded on to the service itself. And then the DNS provider, I've just overridden whatever it is and put the core DNS as the DNS provider internally to Kubernetes cluster. So some various references for the documentation. So each section has different pieces. You can see services there. We'll tell you what sort of things you can configure in the services, what the attributes are. There's quite a bit of documentation out there. It does take a bit of digging and getting around to work it out. But like I say, this builds a very basic cluster. You would then want to go off and either use things more detailed in your RKE cluster configuration, or you might decide that actually once I've got the basic up, I might use Helm or Flux to do the rest of it. So once we've got our master.yaml file, so the file has to be called master.yaml that we've just been looking at. If you've called it that, and if you're in the same directory where master.yaml is, and RKE has been installed in, say, /bin, okay, or at least in the path somewhere, RKE up will build the cluster anew. Okay, there are options to be able to do update. I think if I remember right, it's --update only or something like that. But again, RKE --help will tell you what the commands are, and RKE up --help will tell you about the up options and features. If you're not in a directory where the file is, or if you've named the cluster.yaml something different, you can use the --config option to RKE up, and then give it the path, absolute relative, whichever is easier to get to, and the file name to tell it which file you're actually using. And there's a reference there, an introduction to RKE, which talks to you about how to get the help from the command and so on and so forth. So my GitHub project was a little sort of trial and error of, could I do this with VirtualBox, and could I set up an RKE cluster? There is, if you go and look on RKE Rancher's website, a VirtualBox environment to actually go and do this. But again, it only really builds one, and building a Kubernetes cluster of one is really easy. There's loads of those out there. You don't even need RKE to do it. But if you wanted to build a full cluster, that becomes a little bit different. So it's a Vagrant build, mine, but not Vagrant at the same time. HA proxy is built for using Vagrant, but the rest of it's used by building a hybrid VirtualBox environment that uses a Vagrant box. So I couldn't be asked to get hold of an ISO and download it. I've already got the virtual boxes, so let me launch those using VirtualBox. Make the configuration changes that I need for my hosts, so that I've got the two networks that I use and not the annoying 10.2.15 NAT network that VirtualBox brings up. This does restrict you a bit because it means you need VirtualBox's images that are passworded as Vagrant. So quite a few of them have root Vagrant and Vagrant as their username and password, which makes it easier to start sort of copying files and things on there to make it work. And I've also got my HA proxy load balancer, and as part of the Vagrant build, there is also a Rancher web UI VM that can be spun up as well, a separate feature. So let's go and take a look at the code and how this thing builds, and just basically show you, once it's up and running, the sort of things that you can see. Okay, so let me just describe to you very briefly, before I run the system up, what my code actually does that's on GitHub, just in case you want to download it and play with it and sort of modify it according to building your environment itself. So we have the README. The README itself tells you about the configuration, HA proxy, setting it all up, the scripts to run, and how to then sort of get your kubeconfig down to your local machine if you want to actually run Kubernetes, kubectl, sorry, from your local machine rather than on the master itself. So it all starts in the launch. I go off and, because I've got multiple network interfaces on some of my machines, this just goes off and grabs the one that's currently using the 192 address within my private network. I've got a host list here, so I can change that if I want to change the names of my hosts or whatever it is in here. But in particular, you'll see in the code there's a little check to see whether RKE master is there or not. I've got a configuration file, so this allows you to change some values. If we go and take a look at this in source, the config file itself says, okay, what's the VM user that I want to log in with? What's my gateway? So in my office, this is my gateway. What's my DNS server? I need to change that because it's this one at the moment. And what's the subnet that I'm working on within my office or home address, and what's the DNS name for my server. The password for Vagrant machines, how much RAM I want to use for each particular machine. The HA proxy will use 1 gig, it doesn't need 2048, but if I'm on certain machines I can up that to what I need. And then the VirtualBox network interface type that we want to use. And then we've got a few variables to export. There's a few missing here because RAM hasn't been exported, not that it needs to because it all runs there, but we'll make sure that the NIC, the type, and all of these variables are exported for use in the program. So the launch then goes off and says, okay, I've got these nodes to build, import this, so we've got all the information there. I may in future move this out into config as well. Find my subnet and update the subnet in the etc host file, so each machine gets all the host names accordingly. So if we take a look in etc host, it's literally just a placeholder to get these machines all inside, so that the machines can, for us, conveniently talk to each other. If we want to SSH between them, we can use their host names. Then I've got a little bit of fancy work going on here that basically just goes off and says, have I got my Alma Linux? So this is built on Alma Linux, which is the new sort of free distribution, I suppose, of Red Hat Linux instead of CentOS. So Alma Linux is taken over from the CentOS side of things. And if it's not there, just download it. Okay, and then it goes and gets a special parameter from the box OF that will get me the operating system type, actually the name. So when VirtualBox or when Vagrant runs, it loads up an image, and that image actually gets named within VirtualBox. And what's happening here is this is getting me that name, because then I want to be able to change that name so that my system will have the name that I want it, i.e. RKE Worker 1 or Node 1, whatever it is that I need to be able to have. So then I'll go through each machine and we say vbox manage list machine to see if it's there. If it's not been built, then we import the box. We change the box name to the machine name, so that's going to be one of RKE Node 1, 2, or RKE Master. We skip the proxy, obviously, for this one because it's built using Vagrant. We modify the VM so that we change the RAM. VRAM's irrelevant, we're not using graphical environments. We're using Bridged for our public network so that we can actually see it on our machines within the office. The NIC type that we saw as a variable in there, tell it that it's connected when it's switched on and which adapter to use. So that's where my NIC piece comes in to identify what I've actually turned on. We then also add the internal network, so there's our internal network of the 10. And last but not least, just change the boot order so that I get the disk first and DVD and so on and so forth. Then we start up the VM. So if the VM's not running, start it, and then we go on and wait for... This doesn't always work for some machines. I tried this with some of the Ubuntu images and it doesn't propagate the guest property, so it works fine on Alma Linux. So that's why this is built using Alma Linux, and it gets us the IP address here. And the reason for that is it starts up as a DHCP IP address, and I need to do a few things before we run. So we sleep for a bit until we actually get the IP address, write out the IP address, and then we wait until we can SSH onto the machine. So this is a quick little bash cheat that, instead of using SSH, allows us to test if port 22 is up and running on that IP from our machine. Okay, so wait until we can SSH. Once we SSH, we copy on our config file. We'll look at that in this, which we saw a second ago, because we use this for other features as well. So we copy up the config file. We copy up the script node.sh. This goes onto every machine because it sets up things like the SSH keys and various bits and pieces. Actually, that's done down here. So the SSH keys go on. This sort of installs Docker and other stuff. We'll see that in a minute. So copy up the SSH keys. For my purpose, I remove the resolver.conf on the machines because I don't want Network Manager playing around with it. I want to point it at my DNS server, so that would have been done with all of your spacewalk or kickstart features and stuff like that. Same with the DNS piece here. So that's what's happening. Uploads the etc hosts file that gets created that we did earlier, and make sure that the node script is executable, and then it runs the deployment for the node itself. Okay, so we'll take a look at these two in a minute. So this runs on every machine. Then I go and modify the IP addresses to the IP addresses that I need. So we set those up, and here we change the IP addresses and the network configuration. And finally, we end up with this temporary file called temp.config, which in the documentation I will tell you don't delete that, because it's just making sure we've got the machines there, and a couple of the scripts rely on temp.config being in place. For the RKE master, then we wait until we can SSH again. Oh, there was a couple of reboots go on up here as well. Once we're there, we check to see if we've got the program called RKE downloaded locally. If not, we get it and we stick it on our machine here in files, so it will be under there, RKE. It's not in the GitHub repository because it's a binary. There's no point putting it in there. Likewise, the same with kubectl. If you haven't got it, download it for you. And then finally, it copies up the master.sh, the provisioning script for that, the full cluster, YAML, and my LB status application that just basically says OK, so that the load balancer HA proxy recognizes it's there. Copies the RKE and kubectl file up into var.temp, and then it moves the full cluster to cluster.yaml, makes the master executable, and then executes master.sh. And then last but not least, fires up HA proxy so that we've actually got a load balancer outside. So let's take a look at the node.sh. As we can see here, it checks. This was originally because I was hoping it would run on both Ubuntu and Red Hat Linux, but it runs best on Alma Linux, so it works out the command. But otherwise, it'll install Docker up here for Ubuntu, installs Docker for Debian down here, for Red Hat down here, adds the user vagrant to the system, so this can be changed to a user that you want to use, disable all the firewalls, and AppArmor, that's the other one that we need to make sure is disabled on the system for Ubuntu. In my case, again, because of the DNS feature, I disabled the resolve D because I don't want it to be using that. I want it to use our DNS server. Make sure that the SSH directories are up. Copy the SSH keys across so that all the machines have the same SSH key. I do both the public and the private keys. I'm being lazy here, but obviously it's only the master that needs the public key. And I've got a little hack down here. There was a bit of an issue with the Calico containers running, and then some of the applications not using the network properly, and we're getting a little error showing up on some of the containers saying networking is not working properly. Digging around on the internet, basically it said create this file as an empty file. So the container network interface of Flannel just needed to be created on there. So that happens on all the machines. Then the master itself, again, loads config. That's been copied up onto the machine. Checks to see if RKE is installed. If it's not, grabs it from vartemp, sticks it in user local bin, makes it executable. For Red Hat machines, user local bin's not there for root by default, so I've also made a link into /bin. cd into root, and then run RKE up. So our cluster.yaml is in this directory already, and this now starts the build of our cluster. At the end of the build, again, the same issue, because what's going to happen is that the 10 flannel conf list, when RKE up runs, actually removes it. So we just put it back in to ensure that everything stays normal. Download kubectl so that we've got a command that we can play around with on the cluster and inspect things and do some stuff, and set up the default for the kube config. So the idea here is that what RKE does, RKE will create you this file in the directory where you run RKE up. And for Kubernetes to work, you can either use the --kube config option when every time you do kubectl. That's a bit of a yawn and a lot of typing. Or in your home directory, you create .kube as the directory itself, and then create the file. Well, actually, you copy kubeconfig cluster.yaml to a file called config inside .kube, and that then sets your default Kubernetes logon. So you can just type kubectl and then whatever command you like. You don't have to worry about it because it's already there. And then last but not least, this deploys my lb status, and that's just a Kubernetes YAML file that if I go and find lb status there, as we can see, it's a deployment, lb status. It launches 2 replicas. I should launch 3 really, because then that way it runs on the cluster as well. And then it's just basically saying lb status. However, by running 2, don't forget to test the networking. It should all sort of interweave with each other, so it shouldn't matter whether one's running on the master and one's running on worker 2, or they're both running on worker 1 and 2. The routing should work happily, and the idea is it's just basically going to send back the word OK. Okay, and we give it a little service, so it runs on its own port 80, targets port 5678 because the HTTP echo container listens on port 5678 by default. And then we've created an ingress rule whereby I've got a DNS name for my DNS location is status.k8.tps.local. So this would need to be updated based on your system. But it's just there as a way of allowing my load balancer to detect the fact that the right places are listening, and if there's a node without the load balancer running, then don't bother. Not the load balancer, the ingress running, then don't bother targeting it. But that is mostly it. And as we can see here, there's the full cluster file that you saw earlier. Yeah, so that's the one that's going to get run. If we wanted to run this manually, we could just up all the machines, copy the stuff on there one by one, and then see how they work. The proxy itself, HA proxy, the config, normal HA proxy configuration, we've got a stats page that will run on 999 under the /stats, and then I've targeted my internal and externals to see where they are and what's actually being available to us. And we bind on both ports here. So with that in mind, let's go and run this from the command line, and then we'll go and install something like sample app just so you can see it actually running, and we'll take a look at the HA proxy. There's also this test script here where if you read the information about this one, this is a manifest that will actually deploy a Swiss Army knife container, there we go, to each of your worker nodes. Then you can run this check build to see whether everything's rolled out, and we can wait for it to be rolled out from that perspective. And then finally you run this shell script, and it goes across and it checks to see whether all of your containers are working. So let's go and fire this up and see what happens. So here we go. Let's start running this. We could launch the individual nodes one by one, or we can specify how many we wanted to, so we can give the command line arguments on the end. If we don't give any, it will just launch all of them. So let's go for that. So we're importing the Vagrant box using VirtualBox. As we can see there, it's gone through, it's already changed boot order, it's waiting for RKE node 1 because it's launched it, and it's changed its name, so now we're just waiting for the IP address using that fancy TCP hack for port 22 to see whether it's launching. Once we've got the IP address, there we go, we can see the DHCP goes off, does a few bits and pieces, it's copied up stuff, and it's now starting to install Docker on the machine. So this is running the node.sh, and once it's finished installing all the packages, it will do a quick reboot and get the address of 61 for the first node, so it might fly past fairly quickly, depends, because once that's happened and it's rebooted and it's got that information, it goes off and starts the next one very, very quickly. You'll see also on the SE Linux, and you should be okay. I've not made any changes on SE Linux here, but I believe actually on the Vagrant image that they've used here, it is disabled. So it's done that, it's rebooted, just saw it there, very, very quickly rebooted, got the new IP address, and now we're starting up RKE node number 2, and that'll go through the same process. That does the node.sh, and so I'll speed this up. So the first part of the master is exactly the same. Starts it up, renames it, waits for it to start up, gets the IP address, and then does the node.sh installation. And so now it starts running RKE. So we're actually now running the RKE. As you can see, it's going off, setting up tunnels, it's communicating with the other 2 nodes as well as itself, and does all of this over SSH. So we can see it starts to download Rancher RKE tools, and each one of these is a Docker container that it's starting to download across the relevant servers, and we can see which machines it's running them on based on the IP address in the square brackets. And so it goes down, downloads that, it tests to see whether they've installed, and it continues on through installing various containers throughout and then making the relevant configurations for us. So here we can see Hypercube v1 20.6. Again, in the cluster.yaml you can also specify versions of services, and that would come under the services section. So that's the end of the RKE install. We do actually have a cluster at this point, but my proxy are going to install first. Okay, so with everything up, let's just take a quick look to see what we've got. So my connect program spots the servers that we've got, so we're going to log on to the master, and we'll just do a quick kubectl get nodes, and so we can see our 60, 61, 62 all up and running, ready. We can see 60 is our master, control plane, the etcd and the worker running on there, and how long they've been up. Again, you saw here my kubectl, I didn't need to specify the kube config cluster, because that's already in my .cube file. And if we do a kubectl get all minus all namespaces, we can see that everything is running on there. So we've got a Kubernetes cluster that's now up and running. So here we can see our load balancer, our HA proxy server. It's port 9999 running on IP address 65, and the /stats according to the configuration that's in there. What we see on here is the front end. We've got the back end. The first 3, these are the 10.0 addresses. This is the private subnets. There is nothing coming out of the cluster on that address. The 10 is purely for our pods and our containers to communicate on. So our external ones, the master X, node 1X, node 2X, these are the 192 addresses. This is the public address, and they're all up. So they're all able to respond to status.k8.tps.local. Now, k8.tps.local is this machine. It's the HA proxy, the load balancer in this case, and everything gets forwarded through. So if we open up and do an http : there we go, status k8.tps local, we get the response OK. So this is coming through our load balancer and then being sent on to the back end and hitting one of the back end servers and responding to us. If we wanted to do that and target specifically a machine, we can do so. Let's just do that next. So let's have a look at the same feature that HA proxy is doing, but what HA proxy is doing is targeting the nodes directly. So if I use curl and send it across the host header of k8.tps.local, and we target our master first, which is node 60, we get OK back. If we do 61, that's the worker node, 62, second worker node. And so effectively we're sending across and proxying through the host header to the cluster at the back end so that the Ingress can pick it up and pass it on to the relevant server. Now, I only remember running 2 LB status checks within the cluster itself. If we do a kubectl get namespaces, oops, I can't do it from here, sorry. Let's connect onto the server. Kubectl get ns for the namespaces. We see, I believe it's in the default, so I haven't put it anywhere else. So let's kubectl get pods, and then we can see the 2 pods that are actually running our status check. Let's see what nodes they're actually on. So if I describe our pods for this one first, let's do a less, and we can see, okay, so the first one is actually running on the master. Okay, let's take a look at the second one, which is this guy here, and we'll less that one as well. And oh, that's not very good, they're both running on the master according to this. Normally they should spread themselves across. That's pretty poor going. But the intent is that, as you can see, the networking is working because we're getting a response on all 3 nodes in this case. So even though both of these are running on the master, it's able to interconnect across both nodes. If we wanted to test the cluster, what we can do here, let me just go into files, and we've got the test scripts here. So if I scp-r test scripts, I'll copy up the sample app as well. To root at 192.168.10.60, that's our server, and if we put it into there, password as we know is Vagrant. Let's then connect back to the master, and we can see these last few pieces that we've got. So if we try the test scripts first, the first part is here, is I can kubectl apply -f01. So let's pop these into place and have them ready to work. O2 is the next piece, and so that's actually going to wait and check and see whether everything's running. So I'm just going to run it as is. Alternatively, you could just run the kubectl command. So this is going to wait for the deployment to succeed so all 3 nodes are up. Once that's done, the command line will come back to me. Okay, so all 3 nodes are up and ready to test. So let's run this shell script test that will test interconnectivity across the cluster that we have. So as we can see here, each node connects to itself plus the other 2 nodes that are there. So we start off with 60 can reach 60 and 61 and 62, 61 can reach 60, 61, 62, and 62 can reach 60, 61, 62. If you get any errors at all, it generally means you've got an issue with the networking in the cluster. Now, as I said, if you try to build this with Vagrant, because of the 10.2.15 network, there is a tendency that it tries to use that to do a lot of communicating across. So that's why it's a hybrid version that I've written here to do the same feature. So we can see that our cluster has worked, and as we say, we've got interconnectivity, otherwise our HA proxy would have gone mad and we'd only see one thing working. So I can delete kubectl delete -f01, oops, -f01. So that takes that whole configuration out for me, and then we can go and have a little look at our simple app, which is a very, very simplistic web service based on the Echo service that we've got. So we've got Apple as one service that basically just prints out the word Apple. on port 5768. Banana does the same. A couple of ingresses in here, so I've got an Ingress DNS and the original Ingress. A couple of these different, so the direct no DNS will actually do it based on using the Ingress and port 80. It works it out itself. And the other one is the other two are DNS based, so I can use this Ingress one here that says, okay, if I hit RDK8 TPS local as the host name, so I've got a wildcard DNS in my DNS server that just has star.k8.tps.local, so I can just keep adding services with that suffix at the end of it, k8 TPS local. And I can target the Apple service and the Banana service, which are mentioned in the two files itself. So all I would need to do is to say rd.k8.tps.local /apple or /banana, and it will come back with the relevant information. So let's just apply each of these as we see fit. So apply the Apple, Banana, and then the Ingress. Oops. Ingress.yaml. Okay, there we go. So that's in there as well. These two are based on the newer APIs. This one, as you can see here, it gave me a warning about the extension v1 beta. So these are based on the newer and more correct way of writing things. But it still works. So that's the handy thing. If I do a kubectl get deployment, or deploy for short. There we go, we can see our Apple, Banana and our LB status is there. Apple's got 2, Banana's only got 1. That's fine because we can still see it. Let's have a look at kubectl get ingress for that, and so we can see we've got our example ingress. That's our rdk8.tps local, so we can see here, and the addresses it's targeting are all the servers that are involved in the same way as the LB status one is as well. They're on there. So I should be able to say curl rd.k8.tps.local/apple, and we get Apple back. And if I say Banana, we'll get Banana back, and we can keep oscillating between those, and I don't even know which one it's actually going to be hitting. But we could do exactly the same feature that we saw earlier, where we can ask it to say host rd.k8.tps.local to test it out, and we can give it any one of the nodes, 10.61, and we would have to put /apple on the end or /banana on the end, and as we can see here, Banana. Okay, so they're there. Now we saw that the Banana is only running on 1, so let's have a look at kubectl get pods for that. So let's find out where is Banana running. So if we describe pods Banana, let's less that, it's running on 62. Okay, so we've already curled 61, but we'll do it just in case again, so we can see that we're running on 62. So let's go back. Yep, there's Banana. So our ingress is going through and pointing into the right location. So we have a fully working Kubernetes cluster with a load balancer to send the traffic to any of the 3 nodes that are running, because we're running all 3 nodes as worker nodes, including the master, which we shouldn't technically do. But that's as easy as it is to set up an RKE Kubernetes cluster. Have fun.